You're falling, not through air, not through water, through space itself. And around you, the universe is doing something impossible. It's changing color. The stars ahead burn blue, impossibly blue. Their light crushed into shorter wavelengths by your acceleration. Behind you, everything fades to red, then infrared, then nothing. The universe itself is disappearing. This is what it means to cross the event horizon. You wouldn't feel it, no wall, no barrier, no moment when you could say, quote, zero. The event horizon isn't a place. It's a moment, a coordinate in space-time where the future becomes singular, absolute, inevitable, where every possible path you could take points inward. Not just most paths, all of them. Welcome to the edge of forever. The story of black holes begins not with Einstein, but with a man staring at candlelight. John Michell, 1783, England. A rector and natural philosopher who asked a simple question: what if gravity could trap light? Newton's corpuscular theory suggested light had mass. Michell did the mathematics. He calculated that a star 500 times the sun's radius, with the same density, would have escape velocity exceeding light speed. He called them, quote, one bodies from which light could never escape. He was right. But he was also wrong, because black holes aren't dark stars. They're holes in reality itself. Einstein's equations predicted them in 1915. Karl Schwarzschild found the exact solution in 1916. While serving in the German army, calculating trajectories for artillery by day, bending space-time in his notebooks by night. He died of an autoimmune disease months later, never knowing what he'd discovered. His solution described a sphere with such extreme curvature that time and space exchange roles. Inside, moving through space becomes as inevitable as moving through time outside. Think about that. Outside a black hole, you can choose where to go, but not when. Inside, you can choose when you hit the singularity, but not whether. Time becomes space. The future becomes a direction, and that direction is down. But let's go back to you. You're still falling, and here's what nobody tells you. From your perspective, the journey inward takes finite time, maybe seconds, maybe minutes. You cross the horizon, you fall. Eventually, inevitably, you reach the singularity. That's your experience, your truth. But to someone watching from outside, you never cross. Never. They see you slow down as you approach the horizon. Your clock ticks slower. Your movements become languid, dreamlike. The light from your body shifts redder and redder. You fade, dim. Eventually, you freeze at the horizon forever, a ghost image smeared across the event horizon, taking infinite time to cross. Both perspectives are real, both are true. This is what happens when time breaks. The universe inside a black hole obeys different rules. Stellar mass black holes, the kind formed from collapsed stars, would tear you apart long before you crossed the horizon. Tidal forces, your feet falling faster than your head. Spaghettification, they call it, with characteristic scientific poetry. Stretched into a strand of atoms, then subatomic particles, then something that has no name because physics itself breaks down. But supermassive black holes? The monsters at the centers of galaxies, millions or billions of times the sun's mass. Their event horizons are vast, gentle. You could cross in comfort, unaware. The tidal forces at the horizon of Sagittarius A star, our galaxy's central black hole, are weaker than Earth's gravity. You could cross into oblivion in perfect peace. Inside, you'd see wonders. The entire future history of the universe compressed into moments. Light from every star that will ever shine, all arriving at once because time has collapsed into a singularity of experience. You'd see the end of everything before you reach your own end. And what waits at the center? The singularity. Not a point in space, we're past the point where space has meaning, but a moment in time. An instant where density becomes infinite, where curvature becomes infinite, where the equations that describe reality produce infinities and therefore produce nothing. They break, they fail, they admit defeat. This is where quantum mechanics and general relativity meet and scream at each other in mathematical languages neither understands. Stephen Hawking proved that black holes aren't perfectly black. They radiate. Quantum effects at the horizon create particle pairs. One falls in, one escapes. The black hole loses mass, slowly, incredibly slowly. A solar mass black hole would take 10 to the power of 67 years to evaporate. That's a 1 followed by 67 zeros. Longer than the current age of the universe by a factor so large, it makes eternity look brief. But they do evaporate. They do end. And when they do, what happens to everything that fell in? The information, the history, the you that crossed the horizon? Nobody knows. The information paradox. It haunts physics like a ghost, because quantum mechanics says information cannot be destroyed, ever. But general relativity says anything entering a black hole is erased from the universe. Both cannot be true, yet both are true. This is the crisis, the contradiction, the place where our understanding ends, and we must begin again. Right now, there's a black hole in the constellation Cygnus, 6,000 light-years away. Cygnus X1. It's feeding. Matter from a companion star spirals inward, heating to millions of degrees, screaming in X-rays before it crosses the horizon and goes silent. The material forms an accretion disk, swirling faster and faster as it approaches the point of no return. Near the horizon, it's moving at half the speed of light. At the innermost stable orbit, 1/5 light speed. Then, it crosses and disappears. Not just from sight, from the universe itself. This is happening right now, while you watch this. Matter becoming nothing, energy becoming absence, reality becoming void. And here's the terrifying beauty. We're connected to them. Every atom in your body was forged in stars. Some of those stars died in supernovae. Some collapsed into black holes. The iron in your blood, the calcium in your bones, they were manufactured in stellar cores, expelled in death throes. You are made of star matter, death matter, the refuse of cosmic violence. The universe makes monsters to make you. In 2019, we photographed one, M87 star, 55 million light-years away. A supermassive black hole 6.5 billion times the sun's mass. The image shows a glowing ring, the photon sphere, where light orbits the black hole, surrounding absolute darkness, the shadow, the event horizon, the edge of nothing. It's the most important photograph in history, not just because it confirms Einstein's century-old predictions, but because it shows us absence. It shows us the shape of emptiness. It proves that nothingness has a silhouette. We looked into the void, and the void looked back. But here's what keeps me awake. We might be surrounded by them. Small black holes, primordial black holes, formed in the universe's first moments. They could be everywhere, passing through our solar system, through Earth, through you, invisible, undetectable, harmless at small scales, but present. You could be sitting in the gravitational field of a black hole right now and never know. And beyond that, speculation, but grounded in mathematics, maybe our universe is inside one. Maybe the Big Bang was a black hole formation viewed from the inside. Maybe every black hole in our universe creates a new universe in its interior, branching eternally, infinite creation through infinite collapse. Maybe singularities don't end. Maybe they begin. This is where physics meets philosophy, where science meets wonder, where mathematics runs out and poetry must take over. Because we've reached the boundary of what human minds can comprehend using human tools. Black holes are real. They exist. We've photographed them. We've detected their gravitational waves when they collide. Events so violent they shake space-time itself, sending ripples across the cosmos that arrive at Earth 1.3 billion years later, distorting our detectors by less than the width of a proton. We've heard them, the universe ringing like a bell from black hole mergers. LIGO detected it. Binary black holes, spiraling inward, 30 times the sun's mass each, merging in a fraction of a second, converting 3 solar masses into pure gravitational radiation. The universe screaming its fundamental equation: mass curves space. Space tells mass how to move, and when mass curves space enough, it creates a trap from which nothing escapes. Not light, not matter, not time itself. So what does it mean? Why do these cosmic monsters exist? What purpose do they serve in the grand architecture of reality? Maybe none. Maybe existence doesn't require purpose. Maybe black holes are simply what happens when matter follows the rules to their logical conclusion. Maybe they're not aberrations, but inevitabilities. Not cosmic accidents, but cosmic necessities. Or maybe they're doors, passages, transitions. Maybe the end of one thing is always the beginning of another, and singularities are the universe's way of creating something from nothing, or nothing from something, in an eternal cycle we're only beginning to glimpse. You're not falling anymore. You're being unmade. Atom by atom, particle by particle, you're being disassembled by gravity so strong it tears apart the fundamental forces holding you together. The electromagnetic bonds between your atoms, the strong force binding quarks into protons. Everything has a breaking point, even you, even matter itself. And in your final moments, stretched across the singularity, experiencing all of time in an instant, you might understand something fundamental about the universe, about existence, about the relationship between being and non-being. Or maybe not. Maybe there's nothing to understand. Maybe the singularity is exactly what the mathematics says, a place where understanding ends, where questions stop, where the universe says, no further. This is the boundary. Past this point, I keep my secrets. We stand on the shore of an infinite ocean of things we don't know. Black holes are the deepest waters, the darkest depths, the places where our maps end and the cartographers write, quote 1, but we keep looking, we keep calculating, we keep building bigger telescopes, more sensitive detectors, more powerful computers to simulate what we cannot see, because that's what we do. We're the universe trying to understand itself. Consciousness examining the conditions that created consciousness. Matter investigating matter. And when we look at black holes, we're looking at the ultimate question. What happens at the edge of everything? The answer waits in the darkness, in the places where time dies, in the hearts of collapsed stars and the centers of galaxies, in the mathematics and the mysteries. The answer waits, and we're falling toward it. Not physically, intellectually, scientifically, philosophically. We're all falling into black holes of our own. The future, the unknown, the inevitable end of everything we know and love. We can't escape it. We can't stop it. We can only fall with grace, with curiosity, with wonder at the journey. And maybe that's enough. Maybe the fall is the point. Maybe crossing the horizon, seeing the universe change colors, watching reality transform into something unrecognizable. Maybe that's not the end. Maybe it's just another beginning, another transformation, another phase transition in the infinite dance of existence. You're still falling. We all are. Into tomorrow, into the unknown, into the beautiful, terrible mystery of what comes next. And somewhere, in a black hole 55 million light years away, the universe is keeping secrets, waiting, silent, patient, infinite.